right, so the last thing we're going to talk about is writing equations and graphing parabolas that are shifted. So all the examples you have seen have been where the vertex is at the origin. So what you want to do is identify, first of all, that this vertex here, or this parabola here, is not centered at the origin because we've got numbers inside the parentheses with the x and the y. So the way that you're going to find what your vertex is just like any other time we've found any sort of shifted center this year. So inside my x, I see x plus 4, which means my vertex is going to be at -4. And I see y minus 2, which means my vertex y coordinate is at +2. Make sure that you're putting the x with the x spot and the y with the y spot. The next thing you want to notice is that this is an x squared parabola. So x squared parabolas are opening up or down. Specifically, this one is going to open down because it is a -8. So we have a vertex at -4, 2 opening down. Once we have that information, you should graph this. So go -4, 1, 2, 3, left 4, up 2, plot your vertex, and then go ahead and just put those branches going down. And it goes off the graph, no big deal. Once we do that, we can go ahead and find that p-value so we can graph and find our focus, our directrix, and our axis of symmetry. Remember, the way that you find that p-value is taking the coefficient of y, so in this case that -8, and setting it equal to 4p. So when you divide by 4 here, you're going to get that p equals -2. So what does that mean? That means your focus is 2 away from your vertex. Well, since my vertex is now at -4, 2, my focus is still going to be inside my parabola. I'm just going to go straight down 2 and put a point at -4, 0. And then my directrix is still going to be 2 away from the vertex, but now in the opposite direction. It's going to be behind my parabola. So for my vertex, I'm going to go up 2 and put that nice horizontal line. And remember that a horizontal line is going to be y equals, and this line goes through +4. And then you want to finish that off with your axis of symmetry, which goes straight through the vertex, and in this case is a vertical line, so we're talking about x equals, and we've got that x equals -4. All right, so let's check out how to write the equation of a parabola that is shifted. So the first thing you need to notice is that the vertex is not at the origin. The vertex is in fact right here, which is going to be at point 1, 2, 3, 2. So my vertex is at the ordered pair 3, 2. So it's helpful, especially if you find where the origin is here, because sometimes the graphs are cropped funny. You want to make sure you're counting from the right spot. So 1, 2, 3, 2. We did that well. Now we want to recognize that this is opening to the right. So parabolas that are opening to the right, first of all, we want to remember that they're y squared. And since it's opening to the right, it's going to be positive. So those are two things that we want to keep in mind. Before we finish off writing our equation, we have to find that p-value. And that p-value is going to come from the distance between your vertex and your focus, or your vertex and your directrix, which p is just going to equal 1. So we can go ahead and fill in that p equals 1. So now when we pop this into our equation, it's going to be a y squared. So y squared. Notice that I put y in parentheses. The reason why I did that is because now I've got this vertex that's not at the origin. So I'm going to write y minus 2 because that's my y coordinate, and then equals 4 times p. I'm going to put that in parentheses right now so we can really see why our final answer is going to remain a 4. And then times x minus 3. And that x minus 3, that's coming from the x coordinate of my vertex, sticking that in with the x. So if you want to write this out for your final answer, you'll have y minus 2 squared equals a positive 4 times x minus 3. Leave your answer like that. You would never distribute that 4 into the parentheses. That's just not how we graph a conic form for parabolas.